So today we're going to learn about percent yield. Percent yield does not only have to do with chemistry, it also has to do with like things in life. It's basically a measure of accuracy or a measure of efficiency. So your learning targets, I can explain the concept of theoretical yield. That's going to be more of a definition or conceptual. And then the other two, I can derive a theoretical yield under specified conditions, and I can calculate percent yield for a reaction. That's can you do math, okay? So we're going to be looking at definitions and a little bit more of math with this set of notes. So some quick definitions. We have theoretical yield versus actual yield. Theoretical yield is the amount of product that may be produced by a reaction under specified conditions as calculated per the stoichiometric equation. Theoretical yield, another way to think about it, is your calculated amount. It's the amount that you make in a perfect theoretical universe, aka math. Math is always perfect. Okay? Math is always comes out to be perfect. So theoretical yield is in a perfect situation. The calculated amount in a perfect situation. Then there's actual yield. Actual yield is the amount that you actually obtain in a lab setting or in a life setting. The difference, theoretical yield is in perfect circumstances. Is actual yield under perfect circumstances? No, right? Not perfect circumstances for actual yield. It's how much we're actually going to obtain. Percent yield is the extent to which a reaction's theoretical yield is achieved, or basically how close were you to what you should have gotten. So your equation is actual yield over theoretical yield times 100. And that's going to give you a percentage, and that percentage is going to be your percent yield. So how close were you to a perfect situation? And down there at the bottom it says, in order to calculate percent yield, the theoretical yield and the actual yield must be in the same units. So for example, I can't have one that's in moles and one that's in grams. I either need both of them to be in grams or both of them to be in moles in order for the math for this to work out correctly. And we're going to be doing this percent yield calculation with our lab that you guys did last Friday. We're going to calculate, you guys are going to do a theoretical yield calculation tomorrow to calculate how much copper you should have produced based off of how much iron left the nail. And then we're going to do a percent yield calculation comparing what you theoretically should have made compared to how much you did make to see how accurate your science skills were in the lab. So kind of cool-ish. So we're going to look at this in terms of food first, because everyone likes food. So cookies. So let's say to make cookies, we need 2 cups of flour, 1 cup of chocolate chips, 1 cup of butter, and 1 cup of sugar, and that's going to give us 24 cookies. So I want you to take a minute and think about how many cookies you can make with 3 cups of flour and 2 cups of sugar. 3 cups of flour, 2 cups of sugar. So we're going to make 36 cookies because flour is the limiting reactant. Now let's say we don't live in a perfect world. So let's say we only make 34 cookies. We're going to calculate the percent yield for these 34 cookies. So I'm just going to kind of do it down here for you guys. So we're going to take our actual, 34 cookies as our actual. And that 36 is called what? Theoretical. Very good. So we're going to take our actual yield, which is 34 cookies. And we're going to divide that by 36 cookies. And multiply that number times 100. And when you do that, you get 94.44%. So making your cookies, you are 94.44% accurate in making the exact amount of cookies you could have made. Percent yield, a good way to kind of think about it is how close are you to a perfect situation, or how close did you get to precisely making the exact amount you could make. In a lab setting in chemistry, in high school, an 80 to 85% yield is pretty good because you're just learning these chemical, like these lab skills. When you get to college, a lot of college professors grade your experimental results based off of your percent yield. If you have a percent yield that's lower than 90, you're not getting an A on the lab. You usually have to have a 90% yield or above to get an A on the lab. or at least where I went to school, that's what they kind of pushed for. But percent yield does not just rely on chemistry. You could also talk about percent yield in terms of efficiency. Like for example, maybe you work at a fast food place and your boss expects you to make like 30 burgers in 30 minutes. Do you think every day you go in, you're going to make those 30 burgers in 30 minutes every single time? Probably not. Maybe sometimes you make more burgers in 30 minutes, or a few times you make less. That's going to be like a percent yield type of equation you could look at there too. Okay. Let's talk about some reasons why we could have had 34 instead of 36. Okay, example problem. So these are similar to limiting reactant equations for problems in the fact that you're going to see two numbers in these problems. You're going to see a number with a product and a number with a reactant. So I'm going to read this out loud to you, and I want you guys, while I'm reading it, to look at the chemical and then look at the equation and think, is that a product or a reactant? Okay. Upon reaction of 1.274 grams of copper sulfate with excess zinc metal, 0.392 grams of copper metal was obtained according to the equation. What is the percent yield? All right, copper sulfate, is that a reactant or a product? That's a reactant. So copper sulfate, it's a reactant. So that makes this our given. Okay. Copper metal. What is copper metal? A reactant or a product? It's a product. So copper metal, in this instance, it is our want. But because it came with an actual number, this actual number of copper is going to be our actual yield. So you are given your actual yield from a specified given. We're going to take this given and we're going to use math to calculate our theoretical yield. So we have our given, we have what our want is going to be. It's going to be copper metal because that's what our actual yield is. And we're just going to do a quick stoichiometry to figure out our theoretical yield. So in theory, how much should have we made in a perfect situation? Is the world perfect? Are humans perfect? No. So is it always going to be 100%? No. If you are always getting 100%, you should not be in high school anymore. You should be a chemist somewhere. So I'm going to move this up just that far so I can fit my right hand here. So the first step you're going to do, we are going to calculate our theoretical yield. So our given in this equation is 1.274 grams of copper chloride. I'll move this up a little bit further so we can see it better. Anytime I start with grams, what goes underneath grams? The molar mass. So we need the molar mass of copper chloride. Did I write? Oh my God, it's not copper chloride. It's copper SO4. Sulfate. SO4. Our molar mass for copper sulfate is 159.61. Fix this. So 159.61 grams per mole. I'm trying to get to grams of copper. So what is my mole ratio looking at this equation? What's in front of copper? What's in front of copper? 1. So 1 copper. What's in front of copper sulfate? 1 copper sulfate. Our actual yield, if you look up at the problem, was given to us in grams. So what unit does our theoretical yield have to be in? Grams. So to solve for grams, the last step I'm going to do is I'm going to multiply times the molar mass of what I want. So the molar mass of copper, which is 63.55. So I will do this calculation really quick for us. So we've got 1.274 times 63.55 divided by 159.61. And I get 0.51 grams of copper. This is called our theoretical yield, or your calculated yield, right? Your calculated amount. Step 2 for our percent yield problems is to then calculate your percent yield. So we're going to use that percent yield equation, which is actual yield over percent yield, or over theoretical yield times 100 gives us our percent yield. So what was my given actual yield in this problem? 0.392? I just can't remember it. 0.392. My theoretical yield is 0.51. We're going to multiply this times 100. And we get 76.86%. Is it terrible? No. Is it good? Also not so much. But there's your percent yield. All right, so now we're going to do a practice problem. First, we're going to read it together. So it says, what is the percent yield of a reaction that produces 12.5 grams of the gas Freon, CF2Cl2, from 32.9 grams of CCl4? We have two numbers given to us in this problem. We need to figure out what exactly they are. Freon, CF2Cl2, is on the right side of my equation, which means it's a product. So this number that they gave to us, 12.5 grams, is our actual yield. And that's our actual yield. Which means 32.9 grams of CCl4 is my given. And I'm going to use that to calculate what? The theoretical yield. So you're going to calculate your theoretical yield of Freon, CF2Cl2. This is your want for your theoretical yield equation. This is your given, the 32.9. Calculate your theoretical yield and then solve for percent yield. I'm going to pause the video right now to give you time to do that. All right, let's check your progress. So our given is going to be 32.9 grams of carbon tetrachloride. So 32.9 grams of CCl4. What is my molar mass of CCl4? 153.81. Perfect. Our middle is our mole ratio, so we want Freon. This is Freon right here, so 1 CF2Cl2 over our given, which is 1 CCl4. What is my molar mass of Freon? 120.91. Okay. After we multiply all of that out, what did you get for your theoretical yield? 25.86 grams of Freon. And then we need to do our percent yield calculation. So I'm just going to move this over a little bit. So we should have our given, which in this instance is 12.5 grams of Freon, over our theoretical yield. So 12.5 over 25.86 times 100, and that ends up giving you 48.34%. Not a very good yield. They probably spilled a lot of their Freon in this instance.